3, 4 zeros of polynomial functions, day 1. Your learning goals are that you will be able to use the rational zero theorem to list possible rational zeros, find zeros, solve polynomial equations, and write a polynomial function with given zeros. So we're going to first look at the rational zero theorem, which is used to list possible zeros. Okay, according to this theorem gives you your list of possible rational zeros. Remember, a zero are your, it could be x-intercepts, solutions, roots. All of those are equivalent to the word zeros. So basically, we're solving this polynomial function. And a rational number are numbers that can be written as fractions. So what you're going to do is you're going to list all the factors of your constant term divided by all the factors of your leading coefficient. That means plus and minus. So all of these are integers. And factors are numbers that will divide evenly into those two numbers. So you always look at the constant term and the leading coefficient. So that will give you your list of possibles. And then from there, you will actually test them. So after you make your list, then you test with synthetic division. Until you get to a quadratic or something that you can factor. And then you can either factor or use quadratic formula to find the other zeros. So you make your list, you test them with synthetic division until you find a factor. Remember, that means that the remainder will be 0. And then you factor, use quadratic formula to find the other zeros. Okay, for example 1, we're giving this function. And so A, we're going to make our list of possible zeros. List of possible rational. Remember, rational number is a number that can be written as a fraction. Zeros. All right, to make your list, remember you look at two things. Your constant and your leading coefficient. So first you write all the factors of your constant. And I always try to go in order from least to greatest. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And then you're going to divide that by the factors of your leading coefficient, which is 1. Plus or minus 1. So what you're going to do is divide each term by the 1 in the denominator, and then you will get your list. Okay, so those are your list of possibles. Remember, your degree tells you how many there are total. So there are a possible of 3 rational zeros. We have to find the solution. So here, you're going to test your possible list. Excuse me. And this is where you just have to do trial and error until you can find one that works. So we're going to use synthetic division. Make sure no terms are missing. 1, 2, -5, -6. So remember, we get that from the coefficients of our polynomial. And then we're just going to test the number. And if you're lucky, you'll get it right on the first try. So I'm just going to try 2. And I'm going to put trial and error. Actually, I'm going to write in your terms. Guess until you get it right. All right, so you bring down the first time. 2 times 1 is 2, add going down. 2 times 4 is 8, add going down. Aha, this is what you want. You want this to happen because that means that you found your first 0, which is 2. So then you take this, your coefficients, and you write your variables back. So now remember, we lose 1. X squared plus 4x plus 3 equals 0. This is a quadratic. So once you get to a quadratic, you're going to either factor or use quadratic formula. So I'm going to factor. 2 numbers and multiply to give you 3. They add to give you 4. Set them equal to 0. Plus the one that actually worked. The one that actually worked was 2. So that'll be x minus 2 equals 0. X plus 3 equals 0. Or x plus 1 equals 0. So your zeros would be 2, which was the one that worked in synthetic. X equals -3. Or x equals -1. So your solutions are 2, -3, -1. Okay, we're going to try another one. This is example 2. Remember, the first thing you do is make your list of possibles. So you're going to look at factors of your constant term divided by factors of your leading coefficient. So 4 is my constant, so plus or minus 1, plus or minus 2, plus or minus 4. Divided by 2, factors of 2, plus or minus 1, plus or minus 2. All right, so to make your list, remember you're going to divide, first you're going to divide everything by 1, and then everything by 2. So plus or minus 1, plus or minus 2, plus or minus 4. And then dividing everything by 2, 1 divided by 2 is 1/2. 2 divided by 2 we already have in our list. 4 divided by 2 is 2, which we already have in our list. So if you already have it, you don't have to repeat it. So then you're going to do a test with synthetic. Two, -5, -6, and 4. Remember, this is when you have to guess. Guess until you get it right. I usually leave the fraction as my last guess, but I'm going to actually test the 1/2 and see what happens. Half of 2 is 1, and then you add going down. Half of -4 is -2. You add going down. Half of -8 is -4. Add going down. And look, we are happy because we found our first 0. So 1/2 is one of our solutions. And then you're going to rewrite this as a polynomial losing a degree. -4x minus 8 equals 0. What this means is we have 2 more to find, because remember your degree, which was 3, tells you how many zeros you have total. And anytime you can make it, you can simplify it by dividing everything by 2, you want to do that. So that's x squared minus 2x minus 4 equals 0. This is a quadratic, and unfortunately you cannot factor it. So other choices you could do is quadratic formula. I should have said you can also use completing the square if you like that method. Okay, so x equals -b plus or minus square root b squared minus 4ac all over 2. So that'll give you 2 plus or minus, all of that equals 20. And you simplify that. 20 is 4 and 5. So 2 plus or minus 2 radical 5 over 2, which equals 1 plus or minus radical 5. So your roots are the one that worked. Don't forget about that one. 1/2, and then 1 plus or minus square root of 5. So actually there are 3 answers. 1, 2, 3. Okay, so in this example, we're going to write the polynomial function. They're giving us a lot of information. N is 3, basically tells us that's our degree. So our highest exponent is going to be 3. They're giving us the zeros, 4 and 2i. Now note, 2i is a complex number, and complex numbers come in pairs. So they're usually plus and minus. For some reason, they don't write the opposite, but you know that if you have a 2i, then you also need a -2i. So actually, there are 4 zeros to match your degree. And then this information we're going to use later to help us write our coefficient or get our coefficient. So that's the information they gave us. All right, so the first thing that I do is I write my zeros as linear factors. So when you write your zero as a factor, you do the opposite. So this will be x minus 4, x minus 2i, and x plus 2i. Your number of factors should match your degree. And then we are going to FOIL. And I would suggest you FOIL the 2 complex numbers first. So you're going to get x squared plus 2ix minus 2ix minus 4i squared. And then these should cancel if you do it right. Don't forget I squared equals -1. So this is actually -4 times -1, which is 4. Now you can FOIL this. X cubed minus 4x squared plus 4x minus 16. And actually, I forgot to write my coefficient, which we're going to find later. Okay, so now you use that information they gave us earlier. They're saying if all the x's are -1, your y value is -50. So all the x's are -1. So that's going to help us solve for this coefficient. -1 cubed is -1. That's -4, -4. And that will be -16, -5, -9. That's -25. So to solve, I'm going to divide. And so A of n equals 2. So what that means is I'm going to multiply that polynomial that I got right here. Everything gets multiplied by 2. So my final polynomial function is 2x cubed minus 8x squared plus 8x minus 32. So that is my polynomial function with the zeros 4, 2i, and -2i.